Yeah. So Alpine is in Star Valley, and I'm in Thane, which is also in Star Valley.
Yeah, I grew up in Idaho Falls, not too far from there. So.
Oh, nice. Yeah. I've been there many times. My dad is from Idaho Falls. Do you go by Tony then?
Oh yeah, much easier.
Yeah. Iago, how you doing?
Good. How are you guys?
Good, thanks.
So Bettina is absolutely thrilled to be a part of this group and representing Bravo Tech, but she is on a plane right now to go to Germany for a couple weeks.
Nice. That would be fun.
So I'm trying to figure out how to use Teams. Can you guys hear me now?
Yes.
All right.
Hey, guy.
Hey, that's my camera is not working, but oh well.
Yeah.
Looks like my Fathom note taker's gonna record things for us, so I'll be able to put a video up on our YouTube channel.
Oh, great.
Nice.
Is your camera just not working or it's not connected in Teams?
Good question. It asked me if I wanted to grant access to the camera and then told me my camera wasn't working. So I really don't. Let me see what this message says. I'll see if I can get it to work. Try unplugging your.
No, go to like three dots and like video effects and settings. Click on settings and make sure your right camera is selected.
Let's see. Integrated web camera is selected and it gives me a little thumbnail. But I'm gonna give me a different background. Wow, that's weird because it's. Let's see if it'll turn on now. Hey, there I am.
There you are.
Hey, guy.
Magical background that I clicked on.
Yeah, you can choose
Yeah.
lots of
Hey,
choose
Will, how you doing?
Hawaii or something. or Mike is in the cabin background. I'm just kidding, Mike.
It looks virtual, but it's my
But it's
background.
real.
You carefully curated that background.
No, it's real. You want me to ring those cowbells?
Absolutely. Of course, more cowbell.
Who's introducing Will?
I will be today.
Okay.
I think I was waiting for everybody to join. Looks like Will is also on. How you doing today, Will?
Hey everyone, I'm a bit under the weather, so my voice might be off, but we're gonna persevere through this. So I'm excited to meet all of you.
I appreciate that. Now, I'll introduce the introduction, and then if I miss anything, please feel free to add to it. But since Bettina is not here today, I will run through that. We'll probably have a couple more people join as you are talking, which is okay. We're a few minutes after the top of the hour, and I just want to give you as much time as possible, and then maybe save some time for questions and answers at the end. But for those of you who do not know Will, which is the majority of us, Will works at Slalom, and he's a data and AI consultant, and he specializes in guiding organizations through the complexities of AI, helping them understand the potential of generative and classical AI. He works closely with customers during the pre-sales and sales engineering phases to craft AI-powered solutions that meet their unique challenges, then guides them through delivery and knowledge transfer. Will develops innovative demos using prompt engineering, chaining, and retrieval augmented generation, which we've talked a lot about here, to solve unique problems, and has built scalable architectures for interacting with structured data, company-specific terminology, and extensive file repositories. By collaborating with major AI companies, he has influenced product roadmaps and introduced new features to enhance user experience. Will creates advanced conversational agents for seamless data interaction and automates the creation of semantic models and metadata assets. Leading training sessions for senior leaders and sales teams, he helps them understand and incorporate generative AI into their daily workflows. With significant experience across the data and AI space, he continuously experiments with new tools to stay current and drive innovation. So it sounds like what Will does is right up our alley. He's a perfect speaker for us. So I assume, Thiago, you set this up?
Yes, I did. So we'll work with our team of data and intelligence within Slalom. So I'm super excited to get some slots from his agenda for him to share some of the work we've been doing and some of the demos that we have. The goal for him is to show some of the assets. If you have more information, feel free to ask any question. This is an open dialogue. And if you want more details, so reach out to me and I can schedule other sessions personalized for you guys. So just let me know. I have another person from Slalom this call as well, Ben Danton. He has some issues with his mic, but he's also from our data team. So, yep, Will, the mic is yours.
All right, thanks everyone. Mike, thank you for the intro. It's quite a good one. So today, got a couple of slides to go through, and then 2 demos as well. One of them is a bit more functional, the other is a bit more technical. As it's been mentioned, feel free to reach out or ask any questions and interrupt me throughout the session. I'm happy to answer them. So let me go ahead and share my screen. Hopefully everyone can see a blue and green slide that says AI Accelerated Engineering.
Yes.
All right, cool. So I want to talk today with all of you about Slalom's approach to accelerated engineering. This is kind of our terminology for using generative AI to move faster and build higher quality products in the software development space. I want to go ahead and ground us by talking about the maturity curve we see at Slalom for AI accelerated development. So you'll see there's 6 levels across here. The first level at 0, no generative AI use. There's no real competitive advantage that we see in this space. A lot of people today are probably pretty familiar with level 1 and level 2 tools. Well, let me explain what I mean by those. Level 1 tool would just be having access to a foundational large language model, like one of the OpenAI models, maybe O3 Mini, GPT-4o. If you're using Gemini, it could be Gemini 2.0 Flash, and so on. We see a 0 to 10% improvement in productivity across the board, generally using these tools. People are able to access them, they can do a lot of different tasks, but because they have no integration with other things, the amount of competitive advantage and productivity you can get from them is relatively small. Moving into level 2, oh, was there a question? Okay. Moving into level 2, we have some more role-specific tools. So think about like GitHub Copilot, Cursor, Windsurfer, etc. This is where we're pairing a foundational model with some kind of context and data, as well as integrations into a tool, so it can start to take actions and be more programmatic. The big benefit here is that you're no longer limited to whatever context you can put into a conversation with something like ChatGPT, and it's able to start to make these tools are able to start to make adjustments and recommendations and such within your environment. In the software space, this might be coming up with code completions, documentation, or even entire functions in something like VS Code. So those both are colored teal, and they kind of fit into this productivity section. Next up, we have differentiation. This is going to be the first demo that we're going to go through today. And this is where we start to really see some substantial gains. What we mean by this is building tools where we're leveraging multiple large language models and plugging them into some kind of process or flow so that they can assist the human working through that process side by side. The way I like to articulate this is by using AI to generate a first draft or like an 80% version of a deliverable that the person can then go and review. We start to see some pretty significant gains in this space. Moving into levels 4 and 5, we start to get into really disruptive impacts. So in level 4, we build up a fleet of agents or a group of agents, however you want to call it. There's lots of nomenclature for it. But this is where we're starting to actually offload specific tasks in the software development lifecycle to agents. What do I mean by an agent? An agent is just an instance of a large language model that we've given context and tool access to, and we have put it into some kind of flow that it's supposed to follow. And we have two approaches. We have supervised and unsupervised agents within this space, and you'll see a little bit more of that in the second demo later today. But the idea here is that we're actually using large language models to complete work tasks, and we're just supervising them as they go along. So this shifts people from a doer role to more of a manager role. And then in level 5, which no one across the industry has quite achieved yet, we get into autonomous AI development, where we really just have humans providing a little bit of input on the strategy or the outcome that we're trying to achieve. And we're using AI to not only do the work, but also configure the process and the agents that we would use to complete that work. I'll pause here for a second and see if there are questions on our perspective on AI accelerated development. All right, cool.
Yeah, sorry,
go
it
ahead.
took me a while
Yeah.
to find the unmute, but so
Sure.
so I think if I understood correctly, you're right now building, this is a perspective, but you're also building these types of systems for people,
Mhm.
right? So if somebody came and said, you know, Microsoft or let's say Harvest comes and says, hey, I really want AI throughout our SDLC, you
Mhm.
go in and build a level 4 tooling for them.
Yep.
How
Yeah.
many of you? So I'm a software developer, and I've been doing, you know, I've been involved with this AI thing for a few years now. How many level 4 systems are out there? Do you think? You said no level 5 yet. You haven't seen anybody actually do that, but level 4 systems. Where do you place that?
Yeah, so I don't have a specific count for you. I think it's starting to grow. Agentic AI has been kind of the big theme for 2025. We have our own framework. We call it TaskStream, and I'll be showing that a little bit later. We call it a framework very intentionally because it's a starting place. So it's a library of code. We can run it on our MacBooks. We can run it on the cloud, and it allows us to stand up agents and give them tasks to do. We configure that through YAML files. But there's still some configuration involved. So when we go to work with customers, we've worked with a lot of customers in the finance space and a couple in media as well. We'll bring that framework, i.e. TaskStream, and then we'll start to configure it a little bit to the specific type of work they're trying to achieve. And then we will use that as an accelerator. So when Slalom is doing software development for that customer, we're using TaskStream to help us work faster. Does that help answer your question?
Yeah, that is really helpful. Thanks. That's about what my experience is too. I see people putting, these deeper and deeper into their systems. So I don't know. I love the way you've kind of broken it up. And my take is, like if you're not looking at level 3 or level 4, you're kind of behind the times now. You really need to catch up. So.
Yeah. If there's interest when we get to the demos, we can talk a bit about model context protocol and how that changes this. So we put this perspective together before MCP became very, very popular, as it has in the last month.
Yeah.
In our experience, Guy, one thing that we noticed, and that's why we put like AI is fully integrated on level 4. No company that I work so far is on level 4 still yet. So level 3, between level 3 and level 4, we have some, but we don't have like an example right now that a company that is 100% level 4. Like we have some startups that started fully automated, but they're not representative yet to be like a company that we can use as an example. But we have some between 3 and 4, but not like fully on 4 yet.
Cool. Yeah. Perfect. Thanks.
All right. If there's no other questions, I want to go ahead and jump to our first demo, just to keep us moving from a time standpoint. So we're going to talk about a level 3 solution, and this is something we have at Slalom called Quantum Leap. The backstory behind Quantum Leap is that we have a specific process we go through with all of our customers for agile delivery of software products. We call it PEM, Product Engineering Methodology. And what we've done is we've built this website that uses generative AI to actually take our product owners and product managers through that life cycle, using AI to accelerate all aspects of artifact generation. So what I did yesterday is I went ahead and came up with this mock RFP for a project called AgriSense. And then I came up with some mock interview notes as well. In the real world, we would have project kickoff decks. We might have, meeting notes, RFPs, responses, RFIs, all kinds of artifacts that you would have at the beginning of a project. We upload them all into our tool called Quantum Leap. And then from here, we can actually use AI, or we can type in ourselves different pieces of context. So it's already gone through and looked through our documents and started to generate what it thinks are the right business objectives, the project milestones, the current state architecture of this project, the future architecture, and then the outcomes. And what we're doing here is starting to capture information about the project, which will then influence artifacts that we'll generate in just a second. What's really cool about this is I can go in and I can make whatever modifications I want to, or I can ask Quantum Leap to go through and use all the context it has so far to try to generate what it thinks the outcomes are that we're trying to achieve with this project. Just get the Teams window out of the way. So when I was talking earlier about using AI in level 3 to come up with first drafts to accelerate delivery, this is exactly what I mean. Now, if we come over to our project workspace, I'm not going to go through all these documents, but I'll go through a couple. In our methodology, we typically create a project charter, an epic roadmap, a backlog of epics, architecture diagrams, personas, a quality engineering strategy, and we'll have status reports. We also have this chat where we can have conversations throughout the project. So what I can do right now is go through and select certain documents. I'm going to keep both of them from the project and use those to start building out a project charter. And over here on the right, as you've probably seen with every application now, we have a chat interface. I'm going to go ahead and say, yes, let's go ahead and start building out the project charter. It's going to go through those artifacts and start to come up with an idea of what our charter might be. Let's say, yeah, this is good. Let's go to our next section and talk about mission. It's going to go through and start to write this out as well. And there's some good content here, but maybe I want to make some adjustments and say, have it focus more on ML ops. So I can say something like, update the mission to focus more heavily on ops. And it's going to go through, and because it has all of this context we've generated, it'll make updates throughout that document. So this is a very easy way for our product owners at Slalom to quickly put together artifacts like the project charter using generative AI. You can imagine how much time this might save. I'm going to go ahead and build out some epics as well. So you can see a couple other examples of how this works. And as it's scaling, I'm happy to answer questions that you might have.
Hey, Will,
Yeah,
what LLM are you using for this, and why did you select it?
that's a good question. I can follow up with you. I actually don't know which model we're using on the back end for Quantum Leap. What I can say is that in general, for all the tools that we develop at Slalom, we tend to be model agnostic. The second tool you'll see after this is called TaskStream. And within there, we support all foundational models from the major third-party hosters, like OpenAI, Anthropic, and Gemini. And then we also are able to connect to any locally hosted models, or not locally, but like Hugging Face hosted models, so to speak, where you download a copy of the model, you put it on a container on AWS or on Azure, and spin up an API endpoint. So I can follow up on the specific model that we're using for this, but we tend to design our solutions so we can swap in whichever model makes sense for our customers or from a cost standpoint.
Okay, no need to follow up. I just wondered and wondered why you selected the particular one, but it's all right. You don't need to follow up, but thank you.
Yeah. If you'd like, when we get to the question section, I'm happy to talk through my perspective on how to choose different models. All right. So a couple other things we want to show. Obviously, you can see we're generating different artifacts. We can also create
Hey,
diagrams.
we use Azure OpenAI GPT 3.5.
Thanks, Thiago.
Thanks.
3.5 and 4.0.
Okay, for Quantum Leap.
Yeah, for Quantum Leap.
Cool. Yeah. One other thing that we do try to do with this tool as well is come up with architecture diagrams. So I'll go ahead and generate a sequence diagram and a Gantt diagram for the project. And again, what we're doing here is using the artifacts we've generated so far, as well as different documents we've uploaded to come up with some of these artifacts. And we can open these up. We can save them as Markdown. The other cool integrations we have is when we go to our epics, we can actually tie this into Jira and push epics that are created by Quantum Leap into Jira so that developers can start working through them. Again, this is one way we're approaching the front end of software development from the artifact generation side to take an idea and some requirements and build out everything we need for a developer team to start working on it. Any last? Oh, go ahead.
I was just say very cool. This is I've been doing it in a different way, but mine's a lot more manual. I love how open this is, where you can everybody can see it. And do you then do you produce like a PDF document that's kind of the standard? Or I saw there's a place you can lock things as well. So I guess once you're approved and everything is solid, you need to lock it so that it's like, this is what we agreed to do kind of thing.
Yeah, so if you go back to like our charter, you can see the content we generated earlier is still there. So this stays in our session state. We can hit this button to restart and clear content out. We've also got options down here to copy the content or to export the documents.
Nice.
And this all runs across the workspace. Anyone or any Slalom engagement can bring this tool as a free accelerator when we work with our customers so that we can hit the ground running very quickly when we start off our projects. All right. I'm going to jump back over to PowerPoint real quick. Here we go. and talk about the broader perspective of how we're employing AI. So you just saw Quantum Leap. That's the QL icon in the bottom left, and we have our picture of our software development lifecycle across the top. So we're really using AI in that space to solve the preparation and artifact development when we're planning and mobilizing for a project. There's a couple other tools in the middle, CA or Complexity Analyzer, which we're not going to show today, but we do have a pretty robust tool built where we can pass a code repository into it, and we actually use dependency graphs and large language models to start to assess how complex a project might be. This is really only applicable for modernization or improvement projects, not for greenfield projects. But the real value we have here is we're using generative AI and dependency graphs to understand how complex is a current state environment. How many, internal, external code libraries are we using? Is the code well documented? Is it well written? And that allows us to better scope our work as we're going through the discovery phase of a project. Once we've done that, we have another tool called Data Genius. And this is really designed to take code and write documentation for it if there's no documentation already, as well as translate that code from one language to another. We use this quite a bit for our app modernization projects. And then once we have good understanding of our requirements in the current environment, and we've got documentation for the current code, it's then time to do our actual development work. And that's where accelerated engineering, agentic engineering comes into play. So in this build phase, that's where we're using a framework like TaskStream to really accelerate how we deliver our software. And with that, I'm going to go ahead and jump into our second demo of TaskStream. So let me get a couple of windows open here. I'm going to show you two really simple examples of how this works. Just keep in mind that we can scale this quite a bit. So we're going to start with what we call a simple transform workflow. And I'm going to run this in a autonomous mode to start. So what we've essentially done is loaded up a really simple file, just this one on the left, into TaskStream, and we've asked it to go ahead and write some documentation. So I'm going to start this run. You'll see over here we're making some calls out to Azure OpenAI. It's the model we've picked so far. We're creating some embeddings and then creating an artifact. And in about 6 seconds or so, we've put together this this little document here, which just explains that we're using a helper library to parse command line arguments. And we've put confidence scoring here so that we know that the model has a 90% confidence that this is the correct answer. Behind the scenes, there's some built-in LLM as a judge activities happening where we're looking at the input request and the output to see whether or not another instance of the large language model believes that that's the right answer. To show another example, and again, I'm just keeping this very simple today, we're going to do a directory transform. And I'm going to run this one supervised instead so you can see a couple more features. One of the things that I talked about on our maturity framework is that we want to have humans at level 4 looking at artifacts and acting as supervisors. So in the supervised mode, as we go through each task that it gets to, it's going to ask for input. So in this directory, we've got a couple of different files, and it's asking whether it's allowed to split files. I can say something like yes, mark that done, and then it's going to move on to the next step in its workflow. So now it's going through and trying to summarize this helper code piece, and it's creating artifacts, and down here it's going to show us an output and ask whether or not this is a good answer. And I can say yes it is, or no it's not, and have it try again. So I've really shifted from a developer to a manager through TaskStream, where it's doing the work. And then I can go down here. I can say maybe I do like this answer better. I'll mark that as done and let workflow continue. So you can imagine how much this would accelerate a development team if everyone's working through their tasks using a tool like this, where they're focused on reviewing artifacts and outputs that have been generated initially by a large language model. And I'm going to click through the last couple steps of this so I can show you our dependency graph at the end. Right, so I got this workflow complete. Within task stream, we're able to look at results. So I can go through my task and I can see for each different role, and I'll explain these in a second, what it was doing, what the task was, the expected outcome, and then the answer that it put together, and our confidence. So this is all very helpful for our developers because they're able to see through every single step of the workflow what's been accomplished. The other cool thing we can show too is this dependency graph. So this shows how we're breaking up a workflow into lots of different steps that the large language models are taking action on. So we started with this root directory right here, and then we saw there was multiple files, so we split those files apart into two parallel paths. And you can see we've got this program CS and this helper CS code, and then we're going through and we're extracting technical requirements from both of them. So we're following a couple of steps. Again, this is all defined through a YAML file on the back end that simply explains we want to look at the files in this directory and then start to summarize and extract requirements from them. So these are two very, very simple examples in TaskStream. We've scaled this up quite substantially to work on hundreds of thousands of lines of code in large modernization projects for some of our finance and media customers. But I'll pause here and see if there are any questions before we jump over to one more slide.
Yeah, I have a question. Forgive me if it's still a question, but does this work with software that's a dedicated product, or it can be used when software has multiple integration touch points with other products?
Yeah, it can work for any software development project. So it the places where we've deployed it before, we've done app modernization projects with this, and those customers had multiple integrations. So it's very flexible. I hope I'm understanding your question correctly.
I believe so. Yes, thank you.
Yep. I can show you one other thing real quick.
I got another question too after you show that to us.
Oh yeah, sure. Go ahead.
Well, this you talk about modernization projects, bringing an old code base up to new modern standards. Is that kind of what you mean by that?
That's one of the applications where we've applied TaskStream. So far, that's been our biggest use case where we've applied TaskStream.
Yeah.
But we've also used it for greenfield development.
Okay. Well, and that's so on the modernization, those projects typically, if they're a significant size, you have to go in and kind of strangle out pieces at a time. And I'm wondering from an architectural level, you got to learn the code, which is, I can see this being super helpful. Has this changed that dynamic to where you take bigger chunks? Like the first thing I do is I go in and say, okay, can I carve out a little piece, make good tests for it, and take that into the new system and carve up another piece? And I don't know if you still follow that type of pattern, or if you guys may have approached it completely differently in your work, but if it's, I guess what I'm getting to is eventually I see AI fundamentally changing how we architect apps, because some of these things aren't some of these lower level things, you won't have humans in the loops anymore, and it's going to just really change. And this is one of the changes I could see. Like you could just say, go do this. And when I've tried this on a couple of code bases, they're still pretty small and it crashes. Like it can't go and do a ton of stuff yet. But I'm wondering if you're seeing that change with the way you've done things.
Yeah, so let me go back to this slide. So when we were looking at, let's talk about complexity analyzer earlier. I don't have a demo for this, unfortunately, prepared today. But one of the things we do create are dependency graphs. So when we're going through the code base, we're looking at every single function and creating a node and a graph for that. And then we'll draw edges to show how those functions rely on each other and external code libraries and such. From there, we can take in really large modernization projects, that graph gets very big. You can imagine there's lots of functions calling each other and dependencies and so on, right? There's processes with graphs we can go through to start to kind of circle parts of the graph where we can see everything within this area is interdependent, and we can make a nice logical break for this section of code, and then just focus on developing just that piece. So we're using our analysis to help guide how we break down the project.
Okay, perfect. That's actually a great answer, I think. So it's following the same process that you would do manually, but really accelerating it right now. We're not to the point where we're doing a completely different process because now we have this amazing capacity. We're actually just accelerating what we would normally do.
Yeah, and that's actually a great point to call out. One of the big lessons learned that we've had from accelerated engineering is that we can apply generative AI to different parts of this SDLC, but unless you apply it everywhere, you just shift a choke point for developers from one area to another. So for example, if we're using generative AI just to write code, but we're not also using it upstream to analyze the code base and understand what work needs to be done, then we're going to have a lot of developers sitting idle because they're waiting on requirements and stories from upstream. Likewise, moving downstream, if we don't apply generative AI to accelerate our development of test scripts and actually running test scripts, we're going to be cranking out huge amounts of code and overwhelming our quality engineers.
Good point.
Cool. With that, I want to jump over to this last slide to kind of take what we saw in TaskStream and make this hopefully a little bit more real for you. So this is our app modernization team structure, one of our projects last year, and then it led into this year as well. Across the top, we have our 3 human roles. So we had a solution owner, which is Slalom speak for a product owner / Scrum Master, and then we had 2 Slalom AI engineers. So those are the only 3 people we had on this app modernization team. And then within TaskStream, we spun up lots of different agents you can see across here. We've broken it out into 5 different colors. So up front, we had a series of supervisor agents which were guiding the work. So think about that first step in TaskStream where we saw a file repository. We realized we had to split across multiple files within there. We've got supervisors doing tasks like that. Then we have another agent in TaskStream whose job is just to generate a backlog. We have one that's task is to create Jira stories or to connect with Jira. Maybe one connects with an S3 bucket to grab requirements documents or to look through legacy code or something like that. But we have all these different agents that we're spinning up for that analysis phase of the project. Then the refinement, we're creating other agents in TaskStream whose jobs are to maybe review a story we've created and then make sure that it meets the invest criteria for a good story. We could have another one that then goes through and looks at that and adds acceptance criteria, technical details, and so on. And hopefully you can kind of see as we go through each of these that what's really changing is we're breaking up all of the different tasks you do in software development, and we're creating little agents in the task stream that do just one thing at a time. And we're stitching them all together so that they can work through this process. And of course, we have those supervised and autonomous toggles throughout the process. So they may be things like in review, we might want to always have humans doing a review of the work that the code reviewer or the tester are doing. But maybe for pulling data from S3, we don't feel like we need to review that because we have a high confidence that the agent's always going to complete that satisfactorily. So, pause here and see if there's questions about how to architect some of these agent teams for our solutions. All right. Well, that's the content that we had prepared. I know there's a couple other questions from earlier, so I'll try to answer those. There was one question around model selection. I know Thiago mentioned that we're using GPT 3.5 and 4.0 for Quantum Leap. When it comes to model selection in general, just a couple of things I can share from my perspective. Generally, thinking and reasoning models tend to be better for larger and more complex tasks. So think about like your O3 Mini, your O4 Mini, 2.5 from Gemini, Sonnet from Anthropic, and so on. Those are good models for more complex tasks where you're passing a lot of context and you have to have the model solve a difficult problem. When you're working on smaller, more discrete challenges, your faster foundational models are going to be good for those. For example, we did a project where we were trying to create lots of automated notifications for a customer from their operations center. We found using Claude 3 Haiku, which is a small fast model, was very sufficient for that because we were asking it to do a very simple task, write a 256 character response based on some information. So when you think about model selection, I would encourage you to consider how complex the task is and use that as a guide for what type of model you would select. The question that we get with model selection a lot comes down to vendors. People want to know, should I be using GPT-4.1, Claude 3.7 Sonnet? And to that, I would say what we've observed over the last 2 years is, for the most part, Anthropic and OpenAI tend to lead the pack with the most capable foundational models. Sometimes you have a Llama or a DeepSeek that comes along, and occasionally Gemini, but for the most part, it's OpenAI and Anthropic in the pack. And if you use their top tier model, you're going to get roughly the same result from either one if you have a well-crafted prompt. I actually had a customer who wanted us to prove this, so we put together a pretty robust prompt, and we ran it through Claude 3.5 Sonnet at the time, and GPT 03 Mini High, and we got the same results. So much so that with a blind A/B test, people couldn't tell which one was from one model or the other. So when you're thinking about model selection, as long as you pick from the stronger vendors, it doesn't really matter if you pick OpenAI or Anthropic or Gemini. There are a couple other questions, I think. Anyone could help remind me of those. I'm happy to talk through them. Or if you have new questions, I'm happy to answer those as well.
Yeah, Will, can you give us an example of one of the RAG implementations that you guys have done, maybe with unstructured data, and how you decide what database you guys use when you're doing RAG with structured and unstructured data?
Yeah, sure. So in terms of databases that we'll use, for unstructured data, vector databases are always going to be your go-to. I'm personally a fan of AWS, but I've worked in AWS more than Azure. I also know Google Vertex has vector databases, so does Databricks. So when it comes to selection of that, we typically defer to what our customer's tech stack is. If they don't have a technology stack, we'll help go through an architecture assessment with them to figure out if it makes sense to be on Azure or AWS or something else. But I'll use AWS as an example for this. So we've had customers who have lots of information. One customer had a lot of unstructured data across Confluence, Salesforce, and their website. So what we did is we used some of the connectors that are out of the box in AWS to scrape content from the web and put that into a vector database that was hosted on Kendra in AWS. There's also a Confluence connector you can use to scrape that content into Kendra as well. And then we loaded all of their Salesforce data into Snowflake. And then we were able to stand up some agents on Bedrock. And Bedrock is great. It facilitates knowledge base creation pretty quickly. So you can go through and I think in like less than 20 clicks now, you can build a knowledge base just from a website, which is pretty cool. But then you can add in agents. So set up an agent that would also talk to Snowflake. And within Snowflake, you can create semantic models. And a semantic model really just describes the data in layman's terms. You think about a lot of your tables, and you might have, strange names for columns and tables that wouldn't make sense to an end user. Semantic models are our way of giving context to an LLM, so it can know that when I say product, I mean the category that starts with like P001 or something like that, if it has a different name in the backend. So we'll put that together, pass that context into an agent along with the ability for it to run a query against Snowflake. And then we can have another agent on top that can interpret the user's question and figure out, do we need to go to Kendra and query our structured knowledge base that's built from the website and from Confluence? Or do we need to go to the other agent that talks to Snowflake and run a query against our structured data in Snowflake? Does that help?
It does. And so then do you present, what type of user interface do you give to your customers to use NLP to query that data?
I've always been a fan of just a simple conversational chat. Early in 2023, I started working with Snowflake and using OpenAI and LangChain to build out the Streamlit and Snowflake app. And it was just a simple conversation like what you'd see on ChatGPT. And you could ask questions, and then we used a series of models on the back end to first rewrite the question in a way that was very clear and precise. And then we passed in a semantic model. We used that to create a SQL query. We then check the SQL query to make sure that it's safe, i.e. it doesn't have like an alter or a delete table statement in it. We would then run that and then use another model to interpret the results and write out an explanation of how the SQL query answers the question. And we had another model that would write out some Python code to visualize it. We would then take all these artifacts. We had this little pop-up window with some tabs in the chat. And across the top, you could see like the answer in one tab. And then we had the explanation. And then we had like a data table preview. And we had a visualization as well. And so within the conversation, as you ask questions and we respond to them, you get the ability to see all four of those things.
Interesting.
And that's been a concept that Databricks has adopted. If anyone's used Databricks Genie, they do all that out of the box now, which is very cool and very accessible.
Yeah, I'm interested in why you guys write the SQL query when if you're using an LLM, you should be able to use the natural language processing to do that for you, shouldn't you? Or is there that you're not successful with that, so you write the query yourself?
Let me clarify. We're using a model to write the query. So to do natural language querying, the best way today is to create a semantic model that describes your data and pass that along with the user's question into a large language model and the output of that is your SQL query. So we as humans are not writing the query, the model is. But we're using that query downstream to also help us write the explanation text, and then we're checking the query to make sure it's not going to do anything destructive in the database. Does that clarification help?
It does. But like if you use, say you're working in the Microsoft stack and you're just using, Copilot, you don't have to have it or the model write the query. You can just use NLP to query your own data, whether it's structured or unstructured, without writing SQL.
Yeah, so Copilot's still doing that in the background, you're just not seeing it.
Okay. Yeah, thank you.
Other questions?
Yeah, I'd be really interested in what's on your roadmap. Like, how far out do you guys plan, and especially for your AI tooling and everything, but any other like roadmap? How are you looking at the future right now?
Yeah, that's a great question. So a couple of things that we're looking at. We've already started working on incorporating Model Context Protocol into TaskStream. For those who aren't familiar, Model Context Protocol is a really cool new concept where we can stand up kind of an interface for large language models to talk with applications and services. It's sort of like an API, but it's more friendly to large language models. So we've started incorporating that into our dev environment for TaskStream so that we can have these agents interact with more services. And that's very exciting. MCP is becoming a very fast adopted standard. Services like Microsoft Teams and Jira already support MCP. And if you think about this from a contextual perspective, you could stand up an MCP server on every single application that you have. And then you can connect as many agents as you want to that MCP server, and they can start to interact with it. So you can get a lot of value out of your models interacting with services very quickly. Another thing on our Another thing on our roadmap that we're thinking about from the accelerated engineering standpoint is accelerated quality and accelerated reliability. So accelerated quality is looking at how do we use generative AI to do quality engineering faster and better so we can keep up with all of this code output. Part of that is looking at how do you bake quality in earlier in the process. There's this kind of mantra to shift quality left in the SDLC. And we're exploring different ways to accelerate that even more with AI. And the other area when it comes to reliability that we're looking at is once you've put a product into production, how do you use AI to monitor that product and proactively address issues, whether they're coming up from people's usage or from an update that you push that creates a bug? And we haven't gotten super far with that one yet, but that's something that we're experimenting with now. Does that help a little bit with the perspective on where we're going?
Yeah, that's perfect. I've been starting to experiment myself with, well, so it's a side project for me, but I got a rack in my office now, and I've been experimenting with AI, I guess, rack support, so it monitors the logs and tells you what is wrong, and then pass it to the AI. And AI, if it's within our solutions, we'll just fix it. The agent. Just starting with that. But
yeah, cool. Other questions? Okay. Well, thank you all for your time. I think we're about 2 minutes early. The team's clock was throwing me off. But you all know where to find us. I think Tiago would be happy to make connections, and I'm always happy to connect as well. If you're interested in learning more about how we approach AI, accelerated engineering at Slalom, we also do a lot outside of the AI space. Thank you so much for your time. It's been great to present, and I hope you all have a great day. Mike, I don't know if you have any closing things to add.
Yeah, thank you very much, Will, for taking the time to do that. It's very enlightening, informative, very helpful for us. We're all very interested in see what's the latest and greatest going on out there, and appreciate your time. So thank you very much. For everyone else in the AI SIG next week, we will be meeting and we'll just have our internal discussion. Hopefully we'll have the demo. Sean was going to do a demo last week, and we're going to try to get him to do it this Friday instead of last Friday. But we had a really good conversation. So if you missed last Friday, go listen to the recording of it. It was really good. Appreciate everyone joining today. Have a great weekend, and we'll see most of you next week. Thanks.
Thanks.
Thanks, Robert, for
Thanks.
joining.
Thank you.